Is Earth being watched by something not of this world?
Oh my gosh, what is that? What is that?
It began with numbers, not light. On a quiet Tuesday in early August, the automated pipeline of the Pan-STARRS Observatory in Hawaii flagged a moving object. At first glance, it was just another faint speck, slipping across the digital star field. But the initial calculations carried a note of unease. The object was bright, brighter than an asteroid at that distance should be, and it was moving faster than most comets ever do on their inbound approach. When astronomers ran the brightness through their size models, they hesitated. If the surface reflected sunlight like a typical asteroid, the diameter would be more than 2,000 kilometers. That's 107 times the estimated size of 3I Atlas. The comparison was staggering. 3I Atlas itself had been a giant among interstellar visitors, perhaps 20 kilometers across, large enough to stir global debate. But this was on the scale of a small moon. In our own system, only a handful of bodies outside the planets themselves are larger. If the surface was dark, absorbing most of the sunlight it received, the true size could be even greater. When orbital calculations came back, the pattern was unmistakable. This was not a long-period comet returning from the Oort cloud. It was not bound to our sun at all. Its path was hyperbolic, the unmistakable signature of an object from beyond the solar system. It was coming in fast, and it would leave just as fast, never to return. The team double-checked and triple-checked the numbers held. An interstellar object, 107 times the size of 3I Atlas, was crossing the boundary into our solar neighborhood. The Discovery report hit the Minor Planet Center's circulars within hours. From there, the news rippled through the astronomical community. Emails were sent to every major observatory. Radio dishes, optical telescopes, and space-based platforms were alerted. The object, given the preliminary designation X3I 2025, was now the highest priority target in the sky. The first observers to catch follow-up glimpses confirmed the sheer brightness. Even at its great distance, it stood out as more than just a point of light. Some detected a faint, extended shape, but whether this was an artifact of imaging or a real structure, no one could say yet. When the numbers were presented at an emergency online symposium, the reactions were split between awe and disbelief. One astronomer in Madrid remarked, "We've gone from pebbles to boulders to mountains. This is a continent drifting between stars." Others were more cautious. Brightness can be deceptive. A highly reflective surface, like a sheet of fresh ice, could make a much smaller object appear huge. But even in the most conservative models, X3I 2025 would still be several times larger than any interstellar object ever recorded. Speed told its own story. Relative to the Sun, X3I 2025 was moving at more than 175,000 miles per hour. In private channels, scientists began discussing scenarios that weren't in the press releases. If an object this size passed anywhere near the planets, its gravitational influence could be measurable. It could subtly alter the orbits of asteroids, comets, even small moons, not enough to cause disaster on its own, but enough to create long-term ripple effects in the architecture of the solar system. And yet, there was no sign of any collision risk. Its trajectory would bring it inside the orbit of Jupiter, before it arced back out into the dark. Close enough for study, far enough for safety, if the models held. By the second day after discovery, the story broke into mainstream media. Headlines screamed of a massive alien object entering the solar system. Talk shows speculated wildly. Could it be an artificial craft? A fragment of a destroyed planet? A rogue moon from another star? Scientists tried to temper expectations. Natural explanations were still the default, but the sheer size and origin of X3I 2025 ensured that speculation would not die down anytime soon. The reality was stark. The object was inbound, and it would be moving at incredible speed during its closest approach. We would have months, not years, to study it at its brightest and largest. Every available instrument would need to be pointed its way. The James Webb Space Telescope would have to adjust its plans. Spectrographs would try to read the chemical makeup from its sunlight. Radar systems, if it came close enough, might map its surface features. But all of that depended on the precision of the next round of observations. For something this massive, missing the window would mean losing a once-in-history opportunity. It was at this point, with the clock ticking and the entire astronomical world watching, that the real investigation began. And with it, the first hints that X3I 2025 was not just bigger, but stranger than anyone expected. The first week after X3I 2025's discovery felt like a controlled sprint. Every major observatory on Earth, and several in orbit, joined the campaign to track and study the object. It was massive, fast, and above all, fleeting. In Chile's Atacama Desert, the Very Large Telescope trained its adaptive optics on the faint speck, stripping away the shimmer of the atmosphere to reveal a sharper point of light. In Arizona, the Large Binocular Telescope alternated between high-resolution imaging and spectroscopy, measuring how the object's surface reflected different wavelengths of sunlight. Across the Pacific, Japan's Subaru telescope searched for any signs of a coma, the fuzzy halo that forms when ices sublimate from a comet's surface. If present, a coma could help explain brightness variations. If absent, the mystery would deepen. The James Webb Space Telescope, with its enormous infrared mirrors, was the only instrument capable of detecting faint heat signatures from an object so far away. But Webb wasn't built to track fast-moving interstellar objects. Its pointing systems were optimized for distant galaxies and relatively slow-moving solar system bodies. Tracking X3I 2025 required a custom algorithm, a predictive leap ahead of the object's position, letting Webb ambush it as it crossed its field of view. After several tense days of planning and simulations, Webb's operators locked in a narrow tracking window. If they missed it, the opportunity wouldn't come again for months, and by then, the object would be farther, dimmer, and harder to study. When Webb's data began arriving at the Space Telescope Science Institute, analysts leaned in. Infrared spectra are like fingerprints. Each dip and spike corresponds to a chemical compound absorbing light at specific wavelengths. The pattern for X3I 2025 was unusual. Yes, there were absorption lines consistent with water ice and carbon-rich material, common in comets and icy moons, but there were also sharper features, narrow and oddly deep, that didn't match simple organic compounds. Some researchers whispered about metals, nickel, iron, maybe even alloys, but no one wanted to leap to conclusions. The signatures could be something exotic, yet natural, the product of formation in a far-off planetary system under conditions alien to ours. By the time the object had crossed within the orbit of Saturn, expectations of a classic comet-like display had evaporated. High-resolution imaging from ground-based observatories showed a crisp point of light, without any detectable outgassing. This absence was more than cosmetic. It meant the faint non-gravitational accelerations seen in smaller interstellar comets, caused by gas jets, were unlikely here. And yet, the motion wasn't perfectly ballistic. Teams at JPL and ESA's Near-Earth Object Coordination Center compared positional measurements from different observatories. When plotted against the predicted path, X3I 2025 was drifting by a few dozen kilometers more than expected. For a small asteroid, that could be written off as thermal effects or outgassing. But for an object this massive, the explanation wasn't so simple. If the deviation held and wasn't an error, it suggested either a highly unusual internal structure or that gravitational tugs from something else were at play. Astrophysicists began running backwards simulations, rewinding X3I 2025's orbit through the galaxy. The best fits pointed broadly toward dense stellar regions within a few thousand light-years of the galactic center. These areas are gravitationally unstable. Stars pass close enough to one another to fling comets, asteroids, and even moons into interstellar exile. But here was the catch. To eject something this big, the original system must have been massive, with gas giants or even larger bodies exerting colossal forces. X3I 2025 might be a fragment of a shattered planet, a stripped moon, or something stranger still. While the scientific work churned quietly, the public conversation went loud. Satellite news channels ran animations of titanic alien ships entering the solar system. Social media exploded with mock first contact countdowns. Scientists repeatedly emphasized natural explanations, but the sheer scale of the object left space for speculation. Could an artificial structure survive the interstellar journey for millions of years? If so, what would it look like by the time it arrived? Multiple sources hinted that certain government agencies had requested non-public briefings from the astronomical teams. Officially, These were about tracking and planetary defense, understanding the gravitational influence and ensuring no collision risk. Unofficially, the interest seemed broader. An object of this mass passing through could alter asteroid trajectories, potentially sending dangerous bodies toward Earth decades or centuries later. The probability was low, but the stakes were high enough for attention at the highest levels. Within 2 weeks of discovery, proposals surfaced for a rapid response mission, a spacecraft designed to intercept X3I 2025 on its inbound leg. The challenges were enormous. Launch windows were tight. The required velocity changes exceeded current chemical rocket capability. Solar electric propulsion could get there, but only after the object was already outbound. Some engineers suggested a ride-along approach, using an already planned deep space mission as a springboard. Others proposed high-speed flybys, using Jupiter's gravity for a slingshot. The likelihood of success was slim, but the urgency was real. If the window closed, no human probe would ever reach it again. Just before the month mark, Webb's processed imagery revealed the first hint of X3I 2025's shape. It wasn't perfectly spherical. One side appeared flattened, like a world scarred by a colossal impact. The surface reflectivity was patchy, bright in some bands, dark in others. This supported the size estimates on the higher end, possibly exceeding 2,200 kilometers. A moon-sized visitor from another star. From the beginning, orbital projections showed no danger of direct impact. The closest approach would keep X3I 2025 far from Earth, closer to Jupiter's orbit than ours. But that didn't entirely remove risk. An object with this much mass exerts measurable gravity over vast distances. Its passing could subtly alter the orbits of asteroids in the main belt, or even long-period comets far out in the Oort cloud. Most of these changes would be insignificant. But planetary defense experts noted a slim, unsettling possibility. A single deflected body could be put on a slow, centuries-long path toward Earth. The chance was minuscule, but real enough to warrant study. Michio Kaku had once said that interstellar objects are proof that the solar system has no borders. With X3I 2025, the point was unavoidable. We like to imagine our planets and moons as permanent fixtures, safely orbiting the sun with the rest of the galaxy out there. But the truth is more like a busy train station, with travelers from other star systems passing through from time to time, sometimes small, sometimes colossal. The arrival of something this large shattered the illusion that our neighborhood is isolated. In astronomical terms, the walls have never existed. Oumuamua had sparked debate over whether it could be artificial. Borisov had reminded us that interstellar comets exist in abundance. 3I Atlas had hinted at a possible uptick in such encounters, but X3I 2025 was different. Its sheer size moved the discussion from speculative curiosity to urgent opportunity. If a moon-sized body from another system was passing through, what could it teach us about the processes that build planets and destroy them? Geologists were suddenly interested. Astrobiologists wanted to know whether subsurface oceans or ancient microbial life could have once existed within it. Planetary scientists speculated about its origin. Was it a rogue planet's shattered fragment, a captured moon thrown free, or debris from a star's violent death? In the public sphere, one question refused to fade. Could something so large be artificial? Most scientists dismissed the idea outright. The energy required to move an object of this mass intentionally would be beyond any known civilization's capability, even in theory. But a minority argued that if the galaxy contains civilizations millions of years older than ours, their engineering might look like magic to us. Still, even the most open-minded researchers stressed the need for evidence. So far, no emissions, no structures, no clear signs of artifice had been detected. If X3I 2025 was artificial, it was hiding it well. By now, multiple governments had taken an interest, not just in the scientific findings, but in controlling access to the data. Some feared that raw observations could be misinterpreted by the public, sparking panic or fueling conspiracy theories. Others saw an opportunity to lead, or at least appear to lead, in the unfolding drama of the largest interstellar visitor ever detected. Funding requests for telescope time soared, Classified briefings multiplied, and in the background, talk of a dedicated interception mission never entirely died, even as its feasibility remained doubtful. For the general public, the idea of a moon-sized interstellar traveler was both thrilling and unnerving. People imagined it dominating the night sky, though in truth it would never be more than a bright star to the naked eye. Still, the scale alone was enough to inspire a kind of existential awe. If something this large could wander in from the darkness without warning, what else might be out there, still unseen? Artists painted it as a black monolith against the sun, or a glittering shard drifting through cosmic night. Filmmakers rushed to adapt scripts, weaving X3I 2025 into their plots. On social media, amateur astronomers live-streamed telescope feeds counting down the days to closest approach. Predictions placed the closest approach in October 2025, when X3I 2025 would pass just inside Jupiter's orbit. For weeks around that date, the object would be at its brightest. This would be the peak moment for spectroscopy, thermal imaging, and any last-ditch attempts at radar mapping. Even at that distance, radar signals would take hours to travel to the object and back. But the payoff could be unprecedented. A surface map of an alien world that had never been bound to our sun. Kaku and other physicists emphasized the long-term importance of these encounters. Each interstellar object is a messenger from a different corner of the galaxy, carrying clues about the chemistry, physics, and history of worlds we will never see up close. X3I 2025's size meant those clues could be richer than ever before. Its surface might preserve geological records stretching back billions of years, untouched by the processes that reshape smaller bodies. If we could study it in enough detail, it might reveal whether planetary building blocks are truly universal, or whether other systems follow different blueprints. Like all hyperbolic travelers, X3I 2025 would not stay. After swinging around the sun, it would accelerate outward, vanishing into the interstellar dark. In a matter of months, it would be too far and too faint for meaningful observation, and then it would be gone. Another nameless wanderer in a galaxy filled with them, carrying whatever secrets it held back into the void.